Hello, and welcome to the National Government webinar, Harnessing Remote Sensing Innovations. My name is Raquel Perez, and I'm a marketing specialist here at Esri. Your presenters today are my colleagues, Mark Saigan, National Mapping Director, Kurt Schwope, Imagery Team Lead, Matt Woodley, the National Government Solutions Engineer, and Kyle Talbot, Imagery Solutions Engineer. First, I'd like to go over a little housekeeping. While you may be muted throughout the presentation, feel free to enter your questions at any time through the questions box on your right. We will be providing answers during the Q&A section at the end of the webinar. There will also be survey questions when you exit the webinar, so we ask that you please take a moment to complete these questions so we may continue to improve the quality of our webinars. This webinar is also being recorded and a link will be provided in a follow-up email. So going over the three topics on today's agenda, we have for you imagery cornerstones for country scale mapping, going 3D to map urban environments, and finally, mapping microgeographies with drones and dash cams. Feel free to email me at raquelperez@esri.com if you have any questions. So to kick things off, I'd like to hand it over to Mark Saigan. Take it away, Mark.
Thanks, Raquel. So many of you are familiar with ArcGIS, and you're probably familiar with remote sensing. I think what we're seeing is an integration of these today, and really remote sensing is foundational to GIS today. It's really the ability of turning imagery into actionable information. We've recently added a number of new capabilities to transform the raw resources of remotely sensed imagery and LiDAR into realistic 3D models. And our goal is to provide you with the ability to capture in great detail the spaces that you have to manage in the built and the natural environments. And once you've captured and created that digital twin, to use ArcGIS to visualize, to measure, to analyze these twins, to make more informed decisions that can be shared with others. It's important to recognize that many of you in national government are increasingly challenged by expanding stakeholder expectations on an escalating variety of informational products that are being required of you. There's faster velocity of near real-time information delivery on greater and greater volumes of imagery and data. Increasing requirements are on you for better resolution of imagery and the granularity of the data that's required. And the quality and the accuracy of the data are all being balanced with privacy concerns. And as we look at the right, we see that all of this is happening in times of reduced budgets, revenues, staffs, and resources. I don't have to tell many of you that you're faced with these things. You're faced with shorter delivery times to deliver results to your users and stakeholders. reduced understanding, public understanding of your organization's importance and relevance in government. And of course, we're all faced with the continuing evolving COVID-19 impacts on our operations. Next. So why should you be interested in harnessing imagery and remote sensing innovations? Well, it's because it has significant benefits to national government organizations and can enable you to do more with less, to be more responsive in getting timely information to your decision makers, increasing your relevance by leveraging remote sensing technology and image analysis for timely information delivery, using faster computing and raster analytics and intelligent AI, or what we call GeoAI, and neural networks to automate image processing. And this provides you savings in time and money and labor. It's increasing your efficiencies and expanding capacity. By automating routine tasks and by allowing your geospatial professionals to focus on higher value projects and outcomes, and enabling us to deliver more information, and ultimately improving our engagement with our users. Next. Today, our world is being challenged ever more by and threatened on many different fronts. And I think the COP26 event the past 2 weeks has really highlighted many of these issues. Next slide. But we recognize that many of you are addressing these big issues that our world's facing, and we applaud you for this. We appreciate the work that you're doing. However, collectively as a community, we still have so much more to do. And at Esri, we truly believe that GIS can help enable us to create a sustainable future together. And imagery and remote sensing are fundamental to these efforts and to your missions. Our goal today is to help you accelerate your work along this journey. Next. And imagery and remote sensing are enabling us to collect, process, analyze, and respond better to all of these issues. This high resolution global land cover from 2020 is a good example. We took imagery from around the globe and brought it together into one high resolution global land cover data set. And this is repeatable because we automated the process. So we're going to be able to do this over various years so we can see difference of time, spatial temporal differences, space-time issues. And it gives us the visibility to many different scales, from global to urban to local levels. And we're going to look at applying imagery and remote sensing at these different scales as we go through this webinar. So first, we'd like to ask you a poll question. We'd like to get your feedback as we go forward here. You should be seeing the poll question now. And so maybe some of you are working at global scales. You're working on these global environmental issues, for example. Or maybe some of you are working at your country level. You're working across your nation. But as we see, many are actually working at a regional and local levels. Or maybe you're working down at a finite high granularity down at the facilities or the campus level. Or maybe you're working on all of these. So I see a number of you are responding. I'm going to give you a few more seconds to respond. Looks like we've got over 50% of you have responded now. And we're going to give you one more second. We're going to close it out. We got 3/4 of you responding. Thank you so much for that. We'll go ahead and close out the poll now. And it's interesting, more than half of you, almost 60%, are working at a regional and local levels. And almost 1/4 of you are working at all of these levels. So this is great feedback for us as we go into the rest of the webinar. And with that, I'm gonna turn it over to my colleague, Kurt Schwope. Kurt?
Great, thank you, Mark, and thanks to everybody who responded to that polling question. That really helps us understand as an audience the types of things you're interested in. As Mark said, we're going to take a journey. It's going to encompass different scales and different dimensions, and we're going to show you some of the best practices and the technology we use to essentially create planetary-wide intelligence using remote sensing. and imagery. One of the key important parts of this, of course, is having the technology to do the remote sensing, the analysis, and working with the imagery. This is what we call the ArcGIS imagery system, and it's tightly integrated with GIS technology. At the core level, it starts with imagery management because there's just so many different up and coming new sources of imagery, remote sensing data that's available. You have to be able to manage that, and you have to catalog it and organize it. And that's the fundamental #1 thing you have to do. But then you have to make that data accurate, authoritative, so you can use it. And this is where photogrammetry comes in. It is being able to take those raw sources of imagery, make them as accurate as your base maps, and then also do nifty things like extract 3D information from that overlapping imagery itself. A new capability that we're starting to see more frequently used is GeoAI, deep learning. And this is the ability to go look into your imagery and actually automatically start extracting features out of that data to populate dashboards and other things. This has really started to revolutionize remote sensing just in the past few years. And more of our customers are starting to use deep learning in their analysis in their process. And then there's finally the traditional remote sensing, spatial analysis, multispectral classification, those types of things where you want to do this broad type of analysis. That is the ArcGIS imagery system. It also includes this ready-to-use imagery content. And Mark was showing that an example of that, our global land cover that we've worked and developed with our partner Impact Observatory. That data set is generated from Sentinel-2 satellite imagery, and it is updated on a regular basis and made available to our customers through our Living Atlas. And more, we are making more content available that you can freely download and access in your analysis directly. For those of you who have used the Living Atlas and are doing remote sensing, look for this new product. You should see it in the next couple of months. It's called ArcGIS Extract. And this is the tool that's going to allow you to go into our Living Atlas, pull out your areas of interest from our Landsat imagery, our NAPE imagery, whatever source you might want to use, and be able to use those pixels on your local machine to do all types of analysis. We have multiple ways of managing imagery in good Esri fashion. You know, why have one way of managing your content when you can have three? And that's kind of a joke, but it's also really kind of important because customers need to be able to do different things and work in different environments when they're processing the imagery. So we have two new products for managing our imagery content. These are, the new ones, is ArcGIS Image for ArcGIS Online. And essentially what we're doing is we're taking the powers of the image server and our raster analytics and making that technology available in ArcGIS Online as a true SaaS environment. So you don't have to worry about loading software, your licenses, whatever. Users can just simply find their imagery, push it up into the cloud, set up raster functions and do all types of analysis against that data, and then share it out across their organization. Now, that doesn't work for everybody. Sometimes there's way too much data to push into ArcGIS Online. So for those organizations that have a large collection of imagery already in place, you can look at ArcGIS Image Dedicated. This is a hybrid solution where you have a data store, we deliver you a server and processing environment, so you don't have to worry about setting up all that IP infrastructure to do that processing. And the two of them come together and you have all the powers of an image server ready and available to your organization. And then there's finally the traditional way, the ArcGIS image server, which is software that you license. And this can work on premises or in the cloud, but you're ultimately responsible as the license owner to set up, configure, and do those types of things. So the goal here is to try to make imagery and remote sensing as easy as possible for you, but give you the flexibility to work in the environment that works best for your organization. When we look at imagery management, there's a couple key important parts. And this is number one is that underlying data model. We support 157 different image types. And so from satellites to aerial photography to drones. And so we have to be able to support that. We have to catalog and make that available. And then even more important, we have to be able to provide those as imagery services so anybody across the organization can access the data without having to go in and find specific files and those types of things. Those imagery services are key to working with large amounts of imagery at scale. And when you get used to talking about imagery services, there are 3 different types that we support with our server technology. I think the one that most people are familiar with is tile cache. And these are your static images, your base maps. The problem with those is they look great, they're perfect for visualization, but you really can't run any analytics against that. So the other 2 types, tiled image and dynamic image, allow you to do much more analytics processing against that data itself. A tiled image is great because it sends the true pixel values down to the client, and then the client can set up and do the processing directly there on the client. Now, dynamic is cool is because you can actually put algorithms against that imagery, and then when you go in and say, hey, this is my area of interest, I want a NDVI, or I want a classified image, or I want to do some type of processing to it, that imagery can have algorithms working against it. The server processes that imagery, and then that is what's served up to the end user. Now, at the end of the day, if you still want to use your image server as a file server and work with files, we provide that too. But it's really important for organizations to start looking at imagery services as the way they move forward into their exploitation. As I said before, these services can have algorithms put against this. We have a solution that we call raster functions, and raster functions can be added to raster function templates. These are a little bit different than GP tools. These are processing capabilities that allow you to be set up and embed as part of your image services, so that dynamic image service can calculate that information on the fly. And what's cool is these raster functions can actually be chained together and put into these templates, and then those can be shared across the organization for advanced processing. And that raster functions can also include our deep learning models. If you go into the Living Atlas now and you do a search on deep learning, you'll see that we have now provided a library of deep learning models that you can add into those raster function workflows and start doing automatic feature extraction from your imagery on models that we've already built. But of course, if you want to make your own deep learning models, we provide that technology as well. So now I'm going to turn it over to my colleague, Matt Woodleaf, and he's going to show you some of this advanced imagery management and raster analytics. Go ahead, Matt.
Thank you very much, Kurt. So as Kurt mentioned, some of the newest innovations around remote sensing are not the sensors themselves, but the storage and the analysis of the image. The first innovation I want to share is the cloud storage of large analysis-ready imagery data sets. With ArcGIS Image Server, ArcGIS Image for ArcGIS Online, and ArcGIS Image Dedicated, I now have a trio of options for accessing my imagery source from the cloud. But stored and shared right from the Living Atlas is the entire Sentinel-2 collection. I can simply drag and drop that into my map, which that means for imagery analysis at the national or regional level, I essentially have a mosaic data set over the entire country or region of interest. You also get all the imagery metadata right at your fingertips. Clicking anywhere on the image brings up the pop-up window. In the pop-up, you can learn the acquisition date, the cloud cover percentage, and even the pixel size of the image. But once you have a large imagery collection, you need to start doing the imagery analysis. And we need ways to make that easier, as image analysts are constantly being asked to do more with less, and the collections of remotely sensed data are growing larger and larger. There simply are not enough people to put eyes on an image. So we can turn to GeoAI and machine learning to automate some of the classic analysis tasks like classification and feature extraction. We have an entire suite of tools for imagery analysis and training deep learning models. but folks still need a way, or still needed to spend significant amounts of time training these models. But there is a simpler way. Right inside the Living Atlas, we can find deep learning models. These deep learning packages are pre-trained models ready for use in the deep learning tools built into ArcGIS Pro. With the built-in tools and the pre-trained models, I can simplify this complex task. All I need to do is point the fields at the right data and browse my deep learning package. I can download the deep learning package to my machine, or I can actually access it right from Living Atlas. Now, I'm only interested in the classification around the airport. So I'm going to tweak a few things in my environment to make that faster. The first thing I'm going to do is tweak the extent. So I don't need to worry about processing all of the images in my collection, which, as we know, is the entire globe. And I can also set my raster size or cell size to 10, which matches the resolution. And I hit run. Now, in the interest of time, I've already ran this. But depending on the number and the power of GPUs your machine has, these deep learning processing tools can take a while. But in the case of my machine, I was able to run these complex machine learning algorithms and get classified pixels all in a matter of minutes. Now let's tackle another common imagery problem. You have a current high resolution image, but it was captured at a time of day where shadows are messing up the analysis. The solution would be to splice in another image to remove those shadows. I had to do some measurements around Busch Stadium in St. Louis, Missouri. But as you can see, my 2019 image is plagued by shadows. Lucky for me, my 2016 image has much less intrusive shadows. So I can splice two images together. With the pixel editor built right in to ArcGIS Pro. All right, so what I want to do is cut out this section. So I'm going to set a new mode and create a polygon around that section. I'm going to set my new target for the 2016 image and replace. Now it looks like the color is a little bit off, but what I can do is use a couple keyboard shortcuts. By pressing Shift and the space bar at the same time, I can color match the image. And just like that, I've spliced in a brand new shadow, an image with less shadows in it. So this pixel editor is great for small scale stuff like getting a new picture of the stadium, but can also be used at a larger scale, particularly for reducing cloudy images or replacing parts of regions that are clouded with cloud-free images. So I'm going to send it back to Kurt now for our next segment.
Excellent. Thanks, Matt. And now it's time for our second polling question. So Raquel, could you go ahead and bring up the second poll? So you can see the polling question. What is your most common important use cases for imagery? Please select up to your top 3 uses. Okay, the results are coming in. We jumped over 60% there. So let's go ahead and close the poll and take a look at the results. So right now it looks like the majority of you are most interested in change detection, which is outstanding, and then closely followed by feature identification, to I assume populated GIS and those type of works. So that's great. Thank you for responding to that. And just a reminder, as we go forward, please go ahead and put any questions you have, anything that we're showing into the question dialog box, and we got the experts on the side answering those questions as we're going through the presentation. So moving on, we're going to change scales a little bit. We're now going to drive down into talking about 3D for visualization and mapping of urban environments. And so we're changing scale a little bit, getting a little bit more high resolution. But of course, the big thing now is being able to work with in the creation of what the community is pretty much calling digital twins. How do we create these 3D models? And at the heart of that is something we call reality capture. And that's the ability to use the tools, the remote sensing tools, the ArcGIS imagery system, to start doing the extraction of 3D information from remotely sensed content to build those 3D digital twins. There's two key components that we have in this, both of them requiring photogrammetry. The first one is working with imagery and stereo imagery, and the second is LiDAR data, and being able to process that, create those 3D models, and make it as accurate as possible. So within ArcGIS Pro now, we have added a number of LiDAR processing tools that are available to you. And these things can range from basic tools that allow you to convert from a digital surface model to a bare earth DEM. It allows you to do automatic classification and extraction of things like buildings and power lines and vegetation. And then we can use those point clouds to create 3D mesh and populate our GIS models to make sure that we have the correct height to our buildings and those types of things. And we have become very sophisticated at being able to extrude the right roof lines and air conditioners and gables and those types of things to make these 3D models from these high resolution point clouds that we're able to get from LiDAR and other remotely sensed sources. Another acquisition that Esri just recently made was for a product developed by a company called N-Frames called Sure. And Sure works with stereo imagery and LiDAR that has been collected in a combined fashion, and be able to generate these very, very detailed 3D meshes over large urban areas. So it's a very sophisticated way to build these digital twins over large areas. So now I'm going to go back to my colleague again, Matt, who's going to show you some of the steps that are involved with creating these digital twins from 3D content.
Thanks again, Kurt. So for this next demo, we're going to focus on the local scale for our workflows. Everyone on this webinar probably recognizes that imagery is much more than just a base map. We can extract foundational GIS data from it. Extracting buildings used to be a time-consuming panning and scanning and drawing rectangles extravaganza. But with the advent of machine learning models, things got faster. However, you still have to spend time training the models. Well, just like we have pre-trained models for land cover, we have them for building extraction as well. Now, to extract buildings out of an image, we only need to use one tool, detect objects using deep learning. My input will be my output will be the detected buildings, and my input raster will be my ortho TIFF. And just like the land cover model, this can be found in Living Atlas as well. We have two flavors of this model. One has been fine-tuned to work well with the United States, and the other has been fine-tuned to work well over Africa. Let's choose the US. There's no additional tweaking I need to run on this tool. So when I run it, we see that the results are pretty good. It picked out almost all the buildings within my extent. But zooming in, we can see that the buildings are a little bit rounded, right? But we can sharpen those edges up with one more tool called regularized building footprint. My input features will be my detected buildings, and the output will be whatever I decide to name it. I want my buildings to have nice sharp edges and right angles, so I'm going to choose that method. So when I run the tool, we can see that my buildings have nice sharp edges. So with two tools in a pre-trained model, I was able to extract about 500 buildings in less than 30 minutes. But so far, we've seen enhancements in the imagery storage and the deep learning models, but there have been enhancements to 3D remote sensing techniques as well. One of the newest trends in GIS is the concept of a digital twin. And to be successful in making a digital twin, you need software that aids in reality capture by rendering 3D meshes. These integrated 3D meshes are a combination of high-density LiDAR point clouds and high-resolution orthophotos processed with the Sure 3D engine. These meshes give us an incredibly realistic view of the urban environment. However, reality can change and buildings go up and down all the time. But when added to the GIS, this mesh becomes an interactive layer and acts as the elevation surface. In fact, I get a suite of tools to manipulate the mesh for my models. In this case, I want to understand how a new development is going to affect the skyline and potentially the property values. I can quickly clip out part of the mesh that is no longer needed and virtually flatten the ground. And then I can add in my new building Revit models, which reveals another enhancement. GIS can now import full Revit models. So now these models can have more context and can be used for further analysis. Now, with our building models in, we can start to use them with our new 3D exploratory analysis tools. I want to analyze how this new building, if built to scale, will affect the viewshed of the building next to it. This is great for planning techniques where we want to understand the property values. Let's create a viewshed. Using the interactive tool, all you need to do is simply click on the building and it knows the elevation and range. We'll adjust some of the properties here to get a proper viewshed. Maybe play with the tilt angle so we can act as kind of like we're actually a human being sitting in this window here. All right, let's spin around. Get a wider angle view here. Spin around, take a look at the viewshed. So to build as planned, the owners of these parcels probably will need to come to some sort of agreement on the purchase of air rights from their neighbors, since it appears that this building will significantly change the view. Revit models in GIS allow us to plan for eventual reality. And now I'm going to turn it back over to Kurt to continue on.
Thanks, Matt. I appreciate it. Raquel, could we go ahead and bring up the third and final poll as I switch over the screens? So our third poll is, what are the most important features that your organization collects from imagery? Okay, looks like the votes are coming in. A little bit over half. Excellent. Well, we just went over that magic 60%. So Raquel, if we could go ahead and close the polls and let's take a look at the numbers. Okay, so that's good. We're in a close tie between land cover, land use, and natural resources, and then closely followed by disaster assessment features. That's interesting, and then buildings and transportation. So thank you so much for your input, and we appreciate your willingness to respond to the poll. So let me go ahead and make sure my screen is being shared. And now it's a time to even push down into a smaller scale. And this particular scale is something that I call microgeographies. And these are just small little areas where it's too expensive to buy satellite imagery or hire an aerial collection firm to go out and get imagery for. And so there's just been kind of this gap, and drones are filling this gap, and you can go out and map these small little areas and then be able to incorporate the information that these drones collect into your GIS, to update your GIS, to do all sorts of things. So the drones have become a very exciting way of collecting and working with imagery to update and build your 3D GIS. The quality, the accuracy, the cost, it's phenomenal on how useful these tools can really be to go ahead and build these 3D data sets. What's nice is that it does support 3 different types of families of remotely sensed products. The first one being those 2D imagery base maps. With the high resolution of the drone and the accuracy that you can get with the ground control, these things can be as accurate to near inches, and they can be used to update. If you're working in an area and you haven't been able to pay for an aerial collection that you use for your base maps, you can actually go out and get a drone, fly it over a subdivision, a new park, whatever it might be, and then just take that resulting base map, that 2D imagery that you get from your drone, and put it into your base map for your GIS. And then you got an updated imagery product that you can use. But then even better than that is the 3D information that you can get from those drones. Now, a lot of organizations can't necessarily afford a LiDAR sensor, which is traditionally used for extracting high resolution 3D. But you can actually use the drone to go out and fly photogrammetrically derived point clouds. Some people call it FODAR, but it's a way of building these really beautiful 3D models from drones. It's not quite as accurate as LiDAR in that you only have one return, a first return. A regular laser-based LiDAR can actually penetrate down through vegetation and other things to create a little bit better result. But still, you're going to see some examples of some tremendous 3D products that have been developed just from stereo overlapping imagery taken from a drone. And then finally are these oriented inspection photos. And this is, we don't want to really necessarily do a whole lot of processing on the imagery. We just want to look at the different images that the drone has collected and do basic measurements and just have a geospatial reference point to where I'm looking and using the data. So those are 3 kind of traditional patterns that the drones kind of use. Now, we do have 2 solutions when it comes to processing drone imagery. First off is our drone to map product. This works on the PC. It's a standalone solution, though it does work very closely with Pro. And it's a very robust capability, and it allows you to take that raw imagery off the drone and go ahead and process it to produce those information products I was just talking about. I also mentioned that it does work with Pro. It doesn't require Pro, but what you can do is you can open up a drone to map project directly inside of Pro and then use all the analytical tools and deep learning tools that Pro offers against your drone imagery. Our other solution is SiteScan. And SiteScan is a 100% software as a solution capability. So it's a SaaS. It runs in the cloud, which is important because then you don't have to make the investment in expensive, high-powered compute software to be able to do the work. It's just a subscription. You go out and fly your drone, you collect the imagery, you upload it to the cloud, you say process, and then you get an email, a little while later that tells you your information products are done and working. Now, the one product that we do have that connects these 2 together is a product called SiteScan Flight. And what Flight does is allow you to actually control your drone to go out and fly in a very specific pattern to collect the type of imagery you need for the information product that you want to develop. Flight works on an iPad, and it's a very robust tool to do that powerful flying, if you will, to collect the imagery in the right way. These are some traditional patterns that people use when they want to fly. If you're just interested in that 2D base map of a large area, fly that mowing the grass pattern. You just have the drone go back and forth, you collect the imagery. You still have to have good overlap, but the ending result is a very high resolution ortho base map and potentially even a good DSM. If you want to get more 3D in your urban areas, then we recommend flying a hatch pattern. And this is where we actually set the camera of the drone off at an angle a little bit instead of looking straight down, and it flies back and forth and then back and forth in one direction and then 90 degrees in the other direction. And if you think about it, that allows you to get all three sides plus the tops of your buildings and other structures. So that'll cover a large area, but also give you that rich 3D that Matt was kind of showing you in the last session. And then if you really want to get good detail in a 3D setting, we can fly an orbital pattern which goes around and around the structure and collects imagery from all the different sides. Another capability that we recently added to this flight planning software is terrain following. And you can imagine if you're flying in a mountainous area, remember the most you can fly your drone is 400 feet above the ground. But if your mountain's 1,000 feet, how are you going to get that mapping, and how easy is it going to be able to control that drone? With the terrain following capabilities of SiteScan Flight, you can load up a digital elevation model, and then it will automatically control the absolute elevation of the drone so it stays a consistent 200, 300 feet above the terrain, so you can collect this very consistent resolution imagery along the side of mountains and those types of very rugged terrain. So that's a great capability that we've recently added. I'm also excited to say that SiteScan Flight now, we have support for a USA American-made drone that is the National Defense Authorization Act compliant. So this is a drone, the Free Fly Astro, that can be used by the US government for going out and flying and collecting information. We just delivered a couple of these drones to USDA a few weeks ago. They're up and flying, and it works with that SiteScan Flight app. Now, I do want to say, if you do have a drone that does not work with the SiteScan Flight app, that doesn't mean you can't process the imagery in Drone to Map or SiteScan. Matter of fact, those software tools can pretty much handle any type of camera on that drone that you want to use and collect with. You know, it's only the Flight app that is somewhat limited in the drones that it supports. And we have a list on our website. If you do a search on SiteScan Flight, you can see the types of drones that software supports. The other thing that we'll show you in a little bit is the importance of being able to bring in good ground control. And you know, the drone has GPS on board, but in a lot of cases that GPS isn't really accurate unless maybe it has a real-time kinetic GPS on board of the drone. But if it doesn't have that, it always pays to have good ground control to improve the accuracy of your output products. And if you want to make 3D products, then you need to have good survey in 3D. Now, you can use the base maps that come with ArcGIS and the elevation data that we provide as a service. You can use that as a base map, but that might not be as accurate as you need for your ground control. So we do allow you to add your own ground control from different types of surveyed in ground control points, those types of things. The important thing to note is that through your processing, we always provide these processing reports that allow you to see exactly how accurate your processing is and your resulting image is, just to make sure that it's authoritative. The one thing I also want to mention about SiteScan, and Kyle will show this here in a little bit, is that it's more than just a processing tool. Whereas Drone to Map is good for processing the imagery, if you want to do any type of real analysis with it, you would then bring it inside a Pro and do the work inside a Pro. Whereas with SiteScan, a lot of these common 3D measurement tools and analysis tools are directly available in the SiteScan interface, which is a web-based, cloud-based solution. So it's a very powerful capability that comes with SiteScan, and you'll see that here in a little bit with the demo. Another thing that we offer is, it's somewhat connected to drone imagery, is something we call oriented image catalogs. Now, this can be imagery that you collect from your drone, but it also can be a handheld camera, like your iPhone, or a dash cam that you have in your car. The only thing that an oriented image requires is that it has an XYZ location and an azimuth and maybe a tip tilt in the direction that the camera is pointing when it took that picture. And the oriented image catalog can read all that metadata associated with all those images and then bring it in and use it inside of your GIS environment. And we'll show you some examples on how this works. It's a very powerful way of, perhaps if your organization is interested, get a dash cam. You can even set up your own street views, driving around your town or whatever it is, and set it up in an app inside of ArcGIS and be able to get that working. So now I'm going to turn it over to my colleague Kyle Talbot, who's going to give a demonstration of the drone capability and the oriented image catalogs.
All right, thanks, Kurt. So I'll start by introducing SiteScan. As you can see, it's able to store and provide access to all of my organization's drone projects right here in a browser. So we're going to go ahead and select this Building E project. Now, this is the newest building that was added to the Esri campus in Redlands. Construction began in late 2018, and we periodically captured drone imagery to show updates during the different phases of construction. So SiteScan organizes these flights into projects, and so all of our flights over the same building can be organized in the same place. We have it lets us store flight patterns as well as ground control points so that they can be used for continuous flights over the area. It also lets you control which members of your organization have access to the project. So we'll open up one of our most recent flights using the newly supported FreeFly drone. So to begin, you can upload your raw photos to SiteScan either directly from the flight planning app or by uploading them through a browser from a storage device or a different folder. And then we can tie those existing ground control point files to the newly uploaded photos to give our outputs much higher accuracy in location. SiteScan allows you to select a wide variety of outputs, starting with this orthomosaic you see here. You can get a single high resolution imagery layer usable for base maps or basic visualization with much greater detail. SiteScan also generates a point cloud from the imagery using structure from motion, and you can create 2D elevation layers from that, including hill shades, contour lines, as well as DTMs and DSMs. And these products are analysis ready, and tools such as the volume measurement allow for quick insight right in SiteScan. And we can even visualize the area in question in a 3D viewer. So speaking of 3D, the point cloud used to derive the elevation products is also available as an LAS file, which can be used for advanced point cloud analysis, just like LiDAR. And as Kurt mentioned, right here in SiteScan, there are some easy tools to write in SiteScan to be able to perform this analysis, such as the vertical measurement tool. There's also an elevation profile tool, and that lets you create a line across the terrain and visualize and get information on how the terrain changes along that path and give specific measurements in the graph. It also includes a photo inspection tool. And what this does is it lets you pick a single point in the point cloud, and it will indicate every individual raw photo that the point cloud is located in. And so this is perfect for advanced inspection workflows and really shows the value of digital twins as an easy navigable system for holding all of your imagery. So finally, SiteScan is also now integrated with the new Sure engine that Kurt mentioned to help take your digital twin to the next level. So the engine allows users to create realistic 3D meshes using only drone imagery with much more detail and accuracy than ever before. These highly detailed scenes are great for visualization, and because SiteScan connects directly with your ArcGIS Online and Enterprise orgs, all the products that we've shown today can easily be shared with others and be integrated with other GIS data to provide greater insight. So for example, we've used these 3D meshes to create a public-facing web app, so anyone with access to the URL can easily view the different stages of Building E's construction throughout time. So we can quickly jump to one of the early stages during construction when the foundations were being put in. And then we can select another flight several months later during one of the middle phases of constructions. Now the flights on the table are detailed and easy to navigate, and they're sortable, so anybody can find the exact flight that they're looking for. And then here we have the most recent flight of the building. And because this web app is powered by ArcGIS Online, we can bring in other layers such as the BIM models of the building. Now this BIM navigator will let us change between various construction phases of the building as well. And it'll even allow us to view and select which floor of the building we want to focus on. And now because the BIM model overlays in the same location as the 3D mesh, thanks to the power of GIS, using the slice tool here, we can actually get a realistic visualization of the mesh and see through it and see the interior of the building as needed. So this is a good example of working with drone imagery, but what if you have imagery taken at ground level that needs to be integrated? Well, for that, we can introduce our oriented imagery catalog and web app viewer. So in this app, we can turn on this layer indicating coverage area of oriented imagery and then select a location on the map. When we select the location on the map, we will then see in the oriented imagery viewer exactly where that location falls within a ground level image. The viewer lets you zoom in and pan around the image, and the map will indicate the viewing field as you navigate. Then you can also indicate on the map all of the individual images where the point falls, and we can see here there's quite a few. So for easier selection, we can open the navigation tool on the viewer and see the camera location of all of those images. And we can select the appropriate angle to get a better look at the area in question. So all of these photos on the Esri campus in this app were captured using a GoPro, which is a good option because it contains all the metadata needed to utilize these images in oriented imagery catalog. And once again, this web app allows you to integrate your imagery with GIS data. So in this app, we've added a layer indicating the location of fire hydrants. So I can select that location on the map and be able to locate that fire hydrant in the image for inspection. The image viewer will also let me overlay any GIS layer that I have into the image itself for reference. And it provides tools for basic image enhancement so I can help make things clearer if the lighting in the image isn't ideal. So these oriented imagery applications not only work in 2D maps, but also can be built into 3D scenes as well. So we've overlapped the same oriented imagery catalog of the Esri campus with LiDAR data that was captured over the Esri campus. So any 3D data or workflows that need to be completed in conjunction with the oriented imagery catalogs can be done here in the same space. And then not to mention that the field of view is much more distinguishable in a 3D scene than in the 2D map. So no matter how you're capturing your imagery of your local assets, it is possible to integrate it with GIS data and work with it all in one place. So with that, I'll turn it back to you, Kurt.
Excellent. Thanks, Kyle. That was a great presentation. You know, it's really exciting to see that level of technology. Well, that's what we had to show today. We took a journey using the ArcGIS imagery system. We started at a very high level, looking at large areas and showing you how we can manage a large amount of content, and then do analysis against that data using standard and deep learning techniques. Then we pushed it down another scale to do kind of citywide 3D mapping using some of the newest technology that we've got inside of Esri to create those high resolution digital twins. And then Kyle just took us on a journey where we made that very detailed mapping of those microgeographies. In this case, our own campus at Redlands, where we mapped that building being constructed over time, and then linked it all together with those oriented images from the GoPro and the iPhone and the drone. So that's it, what we had to present. I'm going to turn it over to Mark, who's going to lead us in the question and answer session.
Yeah, thank you, Kurt, and thanks, Kyle and Matt. I think we've had a great overview of all of the imagery capabilities in ArcGIS. We do have time, a little bit of time for questions. We've been answering questions as we go along. You're welcome to put some questions into the chat. If we don't get to all of them, we will respond back to you after the webinar. While you're putting your questions in, I do want to point out that Raquel has been putting a number of resources into the chat as we've been going along. Certainly feel free to copy those, and I think you'll find a lot of good information in those links to those resources. And again, if there's a question that we haven't, that we have not gotten to or covered today, please put those into the chat. Kurt's answered a couple here. Let's see, we've got another one, Kurt, here from Stephen. For maximum accuracy, please go over how you select the datum and the projection for your 2D and 3D maps.
Yeah, you know, that's a good question, and it's always a big challenge that we have. I'm gonna let Kyle kind of describe that in some detail as the solutions engineer. We have just recently added new tools inside of Drone to Map to get and ensure that accuracy of different datums. Kyle, do you have a kind of a good answer on how they can work and select different datums for that accuracy?
Yeah, I mean, there's, especially when you're working with, you know, from a SiteScan perspective, there's so many of these local datums and you know, the various UTM zones. I would simply just do some research before you go into your before you start collecting the flight and understanding which local zone is best for you to for best results for your flight, and then essentially to enhance that accuracy, ensure that when you're collecting your ground control points, that you're collecting them within the same datum as well. And so a lot of times those high accuracy GPS devices, the Trimbles, will have those options for you automatically. And so when you integrate those ground control points into your SiteScan projects, they'll automatically, when you indicate what datum they're in, the project will produce the results to the specified datum of the ground control points.
Yeah, thanks, Kyle. Appreciate that. We are running to the end of our time frame here. We recognize that was going to happen, so we've been answering the questions along the way, and please do send those and we'll answer all of them. Particularly Mike and Stephen, we'll get back to you on your questions. And we got a couple of questions. So this is the last ones is, you know, are the recordings available? They are available. You can go to our National Government Webinar Series where you registered and you will find those recordings. You can also search on them by YouTube by the title on Harnessing Remote Sensing Innovations and the Esri National Government Webinar Series. This is the last of our webinar series that we've done this year. We've done over a dozen. We appreciate all of you participating in this, and I'd like to turn it back over to Raquel. Raquel?
Thank you, Mark. I just want to say thank you to our attendees for joining us today. A survey will pop up once we close out the webinar, so if you could take a few more minutes of your time to submit your answers, we would appreciate the feedback. I want to say Mark, Kurt, Matt, and Kyle, thank you for your engaging presentations, and also a thank you to Steve Snow for providing the resources that I shared in the chat. Have a great day, everyone.